Hello Math 8 students, this is Writing Equations Practice. The first problem says Brenda scored a 74% on her first quiz, a 92% on her second quiz, and she's about to take her third quiz and she wants to make sure she has an average of 84% on all three quizzes. What will she need to score on her third quiz? This problem is dealing with average, so in order to understand this problem we need to understand how to find an average. Average is a concept that we learned many years ago and we've used across all of the different subjects, especially in science. To find an average, you have a list of numbers. You have to add up all of those numbers and then divide by how many numbers you just added up. Let's write that down. Now that we understand average, let's take a look at how that applies to this problem. Brenda scored a 74% on her first quiz, a 92% on her second quiz, and she's about to take her third quiz. That means we don't know what that third score is, but we do know that she wants an average of 84%. So the first thing I need to do is recognize that we know what her quiz score number 1 is. We also know quiz score number 2. And we're asking a question about quiz number 3. So I'm listing the information off to the side. We also need to understand that this is an average problem, but I'm not asking you to find the average. Instead, I am giving you the average, and I'm asking you to find a quiz score that helps to make up that average. So I know quiz score number 1 was a 74%, and I know quiz score number 2 was a 92%. Quiz score 3 hasn't happened yet, so that is our unknown. I will use the variable x. The average, she wants to get an 84%, probably higher. She wants to get at least an 84%. That is the average. That is not her desired third quiz score, but she wants to score high enough on the third quiz score so that her average is an 84%. So I need to add up all of the numbers. That would be quiz score number 1. Quiz score number 2, and quiz score number 3, which is still a mystery. So add up all the numbers. Then divide by how many numbers we just added. I need to divide that total by how many numbers I've added together. 1, 2, and 3 numbers. This still counts as a number because it's a placeholder for an unknown number. So I will divide by 3. When I do this, when I go through this process of finding an average, we want that average to be an 84. We now have an equation to solve, and I want to try and simplify parts of it before I solve it. I can't simplify all of it, but I can at least add together 74 and 92. 74 and 92 add to make 166. But that's just 2 of those numbers added together. I still need to remember I'm adding that third number, x, and dividing all of that by 3, which I know is equal to 84. This looks just like another equation that we've solved in the past, where I can see x is being added by 166, and then we divide by 3. I have to undo those things. So I will begin by undoing dividing by 3. I undo division with multiplication. Whatever I do to one side, I do to the other side, and this has now been undone. The whole reason I chose to multiply by 3 was so that it would undo dividing by 3. That leaves me with just 166 plus x, which is equal to 84 times 3 is 252. There's just one solving step left, x plus 166. We will undo adding 166 by subtracting 166. Whatever I do to one side, I will do it to the other side. And that leaves me with x, which is equal to 86. This means X, which we just solved for, and X represents that third quiz score, so Brenda must score an 86%. If you review problem number 3 is very similar. Selena got a 54% on her first quiz, a 92% on her second quiz, and a 75% on her third quiz. Write and solve an equation to show what Selena must score on her fourth quiz so she has an average of 80% in the class. Notice how similar this problem is to our last problem. Pause the recording and give yourself a chance to get started on it. Now that you've had a chance to get started on it, let's go over it. Again, I'm going to begin by writing down the pieces of information that I know. Quiz number 1 is a 54%. Quiz number 2 is a 92%. And quiz number 3 is a 75%. We know that the average is supposed to be an 80%, but if we read it carefully, we know that that average should include her fourth quiz score, which we don't yet know. So quiz number 4 is unknown. We will use X. Remember, the way we find an average is to add up all of the numbers and divide by how many numbers we just added up. So quiz number 1 is 54. Quiz number 2 is 92. Quiz number 3 is 75, and quiz number 4 is unknown. I'm going to add up all 4 quiz scores and divide by how many scores we just added together. That's 4 scores. When I find the average, I want it to be equal to 80%. Now it's time to simplify before we solve. I don't want to simplify everything, but I can at least combine these like terms. 54 plus 92 plus 75 simplifies to 221. I still need to add X to that, and all of that is going to be divided by 4. That is still going to equal 80, and now I can see what those solving steps must be. X plus 221 was then divided by 4. I undo dividing by 4 by multiplying by 4 and do the same thing to the other side. This now leaves me with 221 plus X, which is equal to 80 times 4, simplifies to 320. X plus 221 can be undone by simply subtracting 221 and doing the same thing to the other side. That leaves me with X, which is equal to 99. In order for Brenda to have an average of 80% in the class, her fourth quiz score must be a 99%. Now let's go back and take a look at problem number 2. A uniform top costs $5 less than a pair of pants. A pair of shoes costs 3 times as much as a pair of pants. At back-to-school shopping, a student buys 6 uniform tops, 4 pants, and 2 pairs of shoes, spending a total of $258. Write and solve an equation to determine the cost of a pair of pants, a uniform top, and a pair of shoes. When I read this problem carefully, I realize there are 3 different quantities. We are purchasing uniform tops, we're purchasing pants, and we're purchasing shoes. I also know the total cost. I'm going to write down little expressions to represent each of these, but I want to do so as I reread this problem. It says a uniform top costs $5 less than a pair of pants. Don't make the mistake of reading this and thinking that a uniform top costs $5. It says a uniform top costs $5 less than a pair of pants. So we're comparing the cost of a uniform top to the cost of a pair of pants. A pair of shoes costs 3 times as much as a pair of pants. Again, that means the pair of shoes doesn't cost 3, it costs 3 times as much as pants. So again, I'm comparing the cost of shoes to the cost of the pants. So I do not know the cost of a top or pants or shoes, but I can't use the same variable to represent all 3 of these. I only want to use the variable x to represent one of them. As we review this, since both the tops and the shoes compare to the pants, it's best if we say the cost of a pair of pants is x. That way, when I write down the cost of tops, which are $5 less than that, it's easy to write that down. A lot of times students don't understand what $5 less than a pair of pants means. So give yourself some examples and make it real. What if a pair of pants costs $20? If a pair of pants costs $20 and tops are $5 less than those pairs of pants, how much will that top cost? It's pretty easy to see that it would cost $15. But how did you do that? What did you do in your head to get to 15? You said, well, $5 less than 20 is 15. But really what you're saying is 20 minus 5 is 15. Let's try another one. What if the pair of pants costs $13? How much would the top cost? $5 less than 13 is 8. But again, pay attention to what you're doing in your head. You say, here's 13, $5 less than that would be 8. So now, instead of saying the pants are 20 or 13, all we know about the pants is that they are x. So how much will the top cost? Look at what we've done. Each time I've taken the pair of pants and I have subtracted 5. This time I don't know exactly what the pair of pants are, but I can still write down x minus 5. So the tops are represented by x minus 5. That shows $5 less than the pair of pants. The next one's a bit easier. Shoes cost 3 times as much as a pair of pants, and I can show 3 times as much by saying x times 3. Most of the time, instead of saying x times 3, we will write 3x, which means the same thing. As I go back and I read this, now that I know that this represents the cost of a top, this represents the cost of pants, and this represents the cost of shoes, now let's take a look at everything that I bought. I bought some uniform tops, and I bought some pants, and I bought some shoes. When I add up all of the totals, the amount that I spent on tops and pants and shoes, that's where I get the grand total. What is that grand total? We spent a total of $258. So now we can start substituting some of this information in. How many tops did I buy? Looks like we bought 6 uniform tops. So I spent this amount 6 times. It looks like I bought 4 pairs of pants. So I spent this amount 4 times. And I bought 2 shoes, 2 pairs of shoes that is. And that means I spent this amount 2 times. When I bought all of those things, I spent a grand total of $258. So this makes sense that all of the tops plus all of the pants plus all of the shoes will equal the total. Now we just substitute in our expressions. I bought not just 1 top, but 6 of them. So this would be representing 1 top. I did that 6 times. Pants are X, but I didn't just buy 1 pair of pants, I bought 4 of them, so I need to show that I did that 4 times. Here's the cost of shoes, but I didn't buy just 1 pair of shoes, I bought 2 pairs of shoes, so 2 groups of 3x. Again, tops plus pants plus shoes is equal to that grand total, which is 258. Now we have our equation. Now we simplify. 6 groups of x is 6x. And 6 groups of -5 is -30. 4 groups of x is 4x. And 2 groups of 3x is 6x. Now we've gotten rid of all of our parentheses. Now we can combine like terms. 6x's plus 4 more x's plus 6 more x's combine to be 16x. Bring this down. That didn't combine with anything else, but it's still part of the problem. 16x minus 30 is equal to 258. Now we can solve our equation. I undo subtracting 30 by adding 30 and balance it by doing the same thing to the other side. Subtract 30, add 30, zeros out, and now all I have left is 16x, which is equal to 288. Just one solving step left. X is multiplied by 16. I will undo that by dividing by 16. Balance it, doing the same thing to the other side, and when I do that, I have x is equal to 18. Again, take that information. What does that actually mean? X represents the cost of pants. So now I know that pants cost $18. Tops are less than that by $5. So the cost of a top is $18 minus 5, or $13. Shoes cost 3 times that amount. So 3 times 18, which is $54. I now know the cost of each of those items, and I have completed this problem. Let's move on, and you're going to see that number 5 is similar. It is not exactly the same, but it's the same idea. Pause the recording and give number 5 a try. Number 5 says, your grandmother is planning her budget for Thanksgiving dinner. She knows a turkey is 5 times the cost of a pie, and a package of stuffing is $2 less than a pie. Grandma plans to buy 1 turkey, 3 pies, and 2 packages of stuffing, and knows it will cost about $46. Write and solve an equation to find the cost of a pie, a turkey, and a package of stuffing. I'm going to begin the same way that I did before. What are the pieces of information that I'm dealing with? And write down expressions to represent them. I know I'm dealing with the turkey. I know I'm dealing with pies. And I know I'm dealing with stuffing. I also have the grand total amount. When I'm trying to decide where to use my variable, I read and I see that turkey is being compared to the cost of a pie, and stuffing is being compared to the cost of a pie. Since both turkey and stuffing are being compared to the cost of a pie, I'm going to use x to represent the cost of a pie. A turkey is 5 times the cost of a pie, so that will be x times 5, or 5x. Stuffing is $2 less than a pie. So, similar to our last problem, if a pie is $10, $2 less than that would be 8. If a pie is $4, $2 less than that is going to be 2. So, since a pie is x, then that means $2 less than that is going to be x minus 2. Noticing each time I'm subtracting 2. And I can't subtract 2 from x, so it stays unsimplified x minus 2. We know the total is $46. With all of that information, we reread one more time, and we see that Grandma is going to purchase 1 turkey, 2 packages of stuffing, and 3 pies. So as I prepare to write my equation, I know that the cost of the turkey plus the money that she will spend on pies plus the money she spends on stuffing is going to have that grand total cost of $46. So now I can substitute in these mathematical expressions. She will buy 1 turkey, which costs 5x. I could show one group of 5x, but one group of 5x is simply 5x. She plans to buy 3 pies. A pie is x. She's buying 3 of those, so pies are represented with 3 times x. Stuffing is x minus 2, but she plans to buy 2 of those, so that's 2 groups of x minus 2. We will be adding these together to get the total of $46. Simplify before solving. We have 5x plus 3x, which I can combine, but I have this which I need to distribute first. 2 groups of 2x is 2x, and 2 groups of negative 2 is negative 4. Don't forget about your 5x and your 3x at the beginning, knowing that all of that added together is 46. Now we can combine like terms. 5x plus 3x plus 2 more x is 10x. Minus 4, because that didn't combine with anything but is still part of the problem, all of that is equal to 46. X is multiplied by 10, and we subtract 4. I will undo subtracting 4 by adding 4. Balancing it, doing the same thing to the other side, and I get 10x is equal to 46 plus 4 is 50. X is multiplied by 10, which I undo by dividing by 10, and I get x is equal to 5. I now know the cost of a pie is $5. I know the cost of a turkey is 5 times that amount. 5 times 5 is $25. And the cost of stuffing is $2 less than that, so the stuffing will cost $3 each. Our final 2 problems are about angles in a triangle. Although we have not had our geometry unit yet, we know from our previous lessons, as well as from the hint, that the sum of the angles in a triangle is 180 degrees. That means when I add up all 3 angles in a triangle, I get 180. In this triangle, the measure of angle B is 20 degrees more than angle A. The measure of angle C is 20 degrees less than the measure of angle A. Again, we're writing and solving an equation to find the measure of all of the angles. Angle A, angle B, angle C, and the total. Again, as I'm trying to figure out where the variable goes, should the variable represent angle A, B, or C, I'm going to look and see if there's any clues. Measure of angle B is compared to measure of angle A. And the measure of angle C is also compared to the measure of angle A. So that's a good indicator that angle A should be x. B is 20 degrees more than the angle A. So I will show 20 degrees more by x plus 20. The measure of angle C is 20 degrees less than the measure of angle A. That is going to be represented with x minus 20. And again, when I add up all of the angles in the triangle, I get a total of 180 degrees. So when I measure angle A and add it to the measure of angle B and the measure of angle C, I get 180 degrees. But A is represented with x, and B is represented with x plus 20, and C is represented with x minus 20. When I add each of these angles, even in expression form, I will get the total of 180 degrees. Now I simplify before solving, and I have 1, 2, 3 x's, and 20 minus 20 combines to be 0. So 3x is equal to, on the other side, I have 180. X is multiplied by 3, which I will undo by dividing by 3. That leaves me with x, which is equal to 180 divided by 3 is equal to 6. Excuse me, 6d. 180 divided by 3 is 60. Let's take that back in. That tells me that the measure of angle x is equal to 60 degrees. B is 20 degrees more than that. 60 plus 20 is 80 degrees. C C is 20 degrees less than that, so that's going to be 60 minus 20, which is 40 degrees. Again, here's a great way to check your answers. I have 60, 80, and 40 representing my angles A, B, and C. I should be able to add those and have it equal 180. 60 plus 180 is 140, plus another 40 is 180, so it checks out that the total is 180. The next problem that is similar to that is problem number 6. Pause the recording and give it a try on your own. Setting this problem up just like the others, since I know it's a triangle problem, I know I'm going to have expressions for angle A, angle B, and angle C, and I know that the total is still going to be 180. Angle B is 4 times the measure of angle A, and the measure of angle C is the same as the measure of angle A. Both B and C are compared to A, so I will use X to represent the measure of angle A. B is 4 times the measure of angle A, so that will be 4 times X. C is the same as the measure of angle A. I used X. The same as that would be another X. Once again, when I add angle B to when I add all 3 angles, A plus B plus C, I get 180 degrees. Angle A is X, angle B is 4X, and angle C is X. When I add these together, I will get 180 degrees. X plus 4X plus another X is 6X, which is equal to 180. X is multiplied by 6, and I will undo that by dividing by 6. That leaves me with X, which is equal to 180 divided by 6 is 30. I now know the measure of angle A, which is 30 degrees, the measure of angle C, which is the same, another 30 degrees, and the measure of angle B, which is 4 times that amount. 4 times 30 is 120 degrees. Again, I can check my answer by confirming that 30 plus 120 plus 30 is equal to 180. 30 plus 120 is 150, and 150 plus another 30 is indeed equal to 180. That's it for this lesson. Thanks for watching. We'll see you next time.